Welcome to the show. I'm your host Anson, and today we'll be having a very special guest. Come on to the stage.
Hi, my name is Alex, and I'm 6 years old.
So guys, Alex is here today because he wants to learn about Half-Life. Am I correct?
Yeah.
So Alex, why exactly do you want to learn about Half-Lives?
Because half my cake is gone! And it's very special to me.
Well, today we'll be having an expert guest who will explain what happened to your cake.
Yay!
Please welcome our guest, Kevin, the science guy.
Hi, my name is Kevin, and I'm a 16-year-old scientist.
Hi, Kevin.
Hi, hello there. So, what's your problem?
So half my cake is gone, and it's very special to me. My father told me it's because of Half-Lives. What's a half-life?
To put it simple, half-life is the time that require a sample to decay. For example, the time that required for half of your cake to disappear should be a half-life.
Is that for every case, like for toys and cookies and food?
No, it's only for radioactive material. So that means your cake is radioactive material.
Oh no! Am I gonna die?
Don't worry about it. You didn't eat it, right?
No, I didn't eat it. Could you explain to me more about half-lives?
Yeah. So unstable nucleus may decay at any time. When there are a big amount of sample, every half-life will have 50% of the sample decay. The atoms are randomly decayed, so the probability for an atom to decay will always be 50% chance.
So, how can half-lives be used in today's world?
Okay, so we could use carbon dating to estimate object's age, and this is a one use for the method of half-life. For example, it takes 5,740 years for carbon-14 to change to nitrogen for a half-life. The mass of the total object is 10 grams, for example, and found that there are 2.5 grams of carbon-14. It can estimate that this object age is 11,480 years.
Well, thank you, Kevin. Thank you, Alex. Well, that's it for tonight. Let's review the following questions on what we learned. Okay, so a radioactive source has a half-life of 3 minutes. At the start of an experiment, 32 milligrams of the radioactive material is present. Determine how much will be left after 18 minutes. Okay, we know that initial amount is 32 milligrams. A half-life will happen every 3 minutes, and that we are trying to find out how much is left after 18 minutes. So our total amount of time left is 18 minutes, divided by the time it takes for a half-life to be made, which is 3 minutes. 18 divided by 3 is 6 half-lives. The half-life equation is 1 over 2n. Since there are 6 half-lives, it becomes 1 over 2 to the power of 6. This equals 1 over 64. We can use this number to times it with our initial amount, which is 32 milligrams, and this will get us our answer, which is 0.5 milligrams. Our next question asks us to extend the curve of this graph in order to show the variation of the activity for a time up to 12 minutes. The A over BQ stands for activity, or the rate of decay. To start off, we have to find the half-life of the radioactive substance. Take the original amount, 400, and times it by a half-life. We get 200. So at 200 BQ, the time is 4 minutes. So 4 minutes equals 1 half-life. With this information, we now know that a half-life happens every 4 minutes. So half of 200 will be 100 at 8 minutes. Half of 100 will be 50 in 12 minutes. Using this graph, our last question is to determine the time after which the ratio of y over x atoms is 7. At 4 minutes, our y is 200 over 400, which is n over 2. Our x is also n over 2, which gives us a ratio of 1. At 8 minutes, y becomes 300 over 400, which is equivalent to 3n over 4, while our x is n over 4. This gives us a ratio of 3. At 12 minutes, our ratio for y becomes 350 over 400, so that is equivalent to 7n over 8, while our x will be n over 8. This will give us a ratio of 7. 12 minutes is our answer.